Hey guys, I received an email inquiring about the principle of zero products, and it can be kind of hard to try to explain, and I don't want to overwhelm you guys. Um, but to try to make this simple for you, this is a rule, a principle that we would use to try to factor polynomials. That's what we're using. That's what I want you to think about here. Unless you're a math major, I'm not really worried about you giving me the definition. Okay. Um, so technically, the rule itself, so what is the product of roots or the product of zeros? So if I were to read it to you, just in case you are curious about what it is, the sum of the roots of a quadratic is equal to the negative of the coefficient of the second term divided by the leading coefficient. Sounds confusing, right? Well, if you were in your just-in-time homework, or if you were, I think this particular person was maybe reviewing some of the assignments that were assigned, or I think it might have been in your study plan working. Um, this is one of those problems that may pop up that you may need to practice because we all have a little bit of trouble with factoring. Um, so essentially what we're doing here is we're factoring. So let's look at this first example. It says solve the following equation. They give us t squared plus 3t minus 54. And it wants us to solve this. Um, well, there's two different ways, or this is a trinomial, okay? Um, so when I think of factoring trinomials, what I first ask myself is my a equal to 1 or is it not equal to 1? And when I say a, what I'm doing is I'm thinking about ax squared plus bx plus c. A trinomial that's written in that form. If my a is equal to 1, which here my a, oh no, a is equal to 1, b is equal to 3, and c is equal to negative 54. Okay, so if a is equal to 1, factoring is a little bit simpler for us. And the reason I'm even talking about factoring, guys, maybe I need to back up just a tad bit more for you guys. When you have trinomials and they're equal to 0, right, and they're asking you to solve them, what you should try to do, if you can, is factor them. Now, if you cannot factor them, then that's when your quadratic equation is going to come in, quadratic formula, right? But we want to try to factor if we can. So that's what we're going to attempt to do here. And it's a little bit easier when a is equal to 1 because you don't have as much to go through and have to think about. So this only applies when a is equal to 1. If a is equal to 1, then what you want to do is look at that last term, that negative 54. Okay? So I know something right now before I go any further. Because that's negative right there, I know that I'm going to have one positive factor and one negative factor. Now we'll talk about in a minute how to figure out which factor is which. But right now, because that last term is negative, I know that when I factor this, in other words, when I get it into factored form, like this, I'm going to have a t first, right? I'm going to end up having a plus something, and I'm going to have a minus something. I'm going to have a positive term and a negative term. Now I've got to figure out what those factors are. And if you have trouble with factoring, the best thing for you to do at this point is write down all your factors of 54. So I know that, give me just a minute. I know that 1 times 54 would give me 54. I know that 2 times 27 will give me 54. I know that 3 times 18 will give me 54. And I know that 6 times 9 will give me 54. And if I keep that list going, what's going to happen is my numbers are going to start repeating. 9 times 6 gives me 54, 18 times 3, and it's just going to keep going. So I'm not going to repeat my numbers. But your goal here is to ask yourself, which numbers are going to multiply to give me that C, which in our case was 54, but will add to give you B, which is 3. Well, I know one number has to be positive and one number has to be negative, right? But because this middle term is positive, that tells me that the largest number will have that sign. So the largest number will be positive. So that tells me that all my smaller factors here are going to be negative. So what you want to do is add these together and see which one of these will add to give you that middle term, which is 3. Well, 54 minus 1 gives me 53. 27 minus 2 gives me 25. 18 minus 3 gives me 15. 9 minus 6 gives me 3. So these are my factors. Maybe I should not circle the 3. I don't want you to be confused. But the negative 6, so the 6 would go here, and the 9 would go there. So I've just factored it. I haven't actually solved it. But my factors, the way you would finish this, guys, is that you would take each one of these. Oops. Let's zoom in some more. You would take each one of these factors. In this case, you have t plus 9. You're going to set that equal to 0. And then you're going to take the t minus 6, and you're going to set that equal to 0. And you want to isolate each one of those variables. You want to solve for t. So for that first one, for t plus 9, if I want to solve for t, what I would do is subtract 9 from each side. And I'm running out of room, but that will leave me, let's put it up under here, that t is equal to a negative 9. Okay, same thing for my 6. Bring that 6 across, which means I would have to add 6, and that leaves me with t is equal to 6. And what you notice is I have two answers here. I have that t can be equal to a positive 6, and t can be equal to a negative 9. And if you notice, positive 9, negative 9, negative 6, positive 6. When your a is equal to 1, it's very easy to find your solutions. Only when a is equal to 1. It's a tad bit different when a is not equal to 1. But your solutions to the equation is going to be the opposite of what your factors are. But that's only when a is equal to 1. And I'm going to work out this second problem, but because I don't want my videos too long, I will save that for a video in itself. So be looking out for that one.